Well, we'll proceed from the previous segment, and in this case, we'll primarily get the scattering amplitude relations. And just to rewrite what we have, remember we had gotten to this point in the previous part. We had a piecewise a general solution at this stage, a fairly general solution uh, of the wave function for scattering off this square well potential. And now then, we simply need to apply our matching conditions at x equal to 0 and at x equal to w, the two edges of that potential region. So I know that at x equals 0, this solution has to match this one, as well as their derivatives have to match. And at x equal to w, this solution has to match with this one. So I get a nice continuous wave function and continuous first derivatives. And that leads to these conditions. Psi at x equal to 0 from the left is going to equal psi at x equal to 0 from the right. The derivative from the left has to be equal to the derivative from the right at x equals 0. And also at w, which adds a little more of a new wrinkle to things. I have to have the wave function continuous, so this is on the left side what it evaluates to, which is this group. And from the right side, equal to this one. And then their derivatives have to match as well. So I took the derivatives and I get these sets of equations. I think you can maybe see if I set the wave functions equal to 0, I'll have a plus r when x is 0, these both become 1, is equal to b plus c, and that's in fact our first condition. The derivatives are similar. One simply has take the derivative of both terms. I'll pick up an ik from this one. I'll get a minus ik from this one because it's going in the opposite direction. And likewise here, I'll get an ik prime because the k is different. And I'll get a minus ik prime. The i's will go out, so that gives me the matching conditions at 0. And at w, here is the wave function on this side. On the left side, at x equal to w, is equal to the wave function on the right side. Now we've got these exponential factors that do not vanish. One can take the derivatives, and you'll get an ik prime b from this ik, and then a minus c ik prime from this one, and then evaluate. And then over here, likewise, an ik, in this case, at e to the ikw. So I have these four sets of equations, and out of that I need to get a relationship ultimately for the transmission amplitude in terms of the incident beam amplitude A. So I need a relation between AT and A. If you look at those, I've got three unknowns essentially, or four unknowns, and I've got AR, B, C, and AT. And treating A as a known, so I've got four equations and four unknowns, and so I should be able to solve those uniquely for really all of those, AR, B, C, and AT. We'll just get AT, the transmission amplitude. What I'll do in the process, I think we've done something kind of similar to this. I'll multiply this one, the equation 1, by K, and I do that, I get this result. And that allows me to be able to add these two equations on this side. The AR term will go out, and I'll get a 2K, and I get some combinations over on the right-hand side as well. In fact, when I add these two, I get 2KA on the left side, and over here I'll get K plus K prime, and I'll get K minus K prime times C. So I get that relation, and then finally I solve that for A. So A in terms of B and C are these. And I do a similar kind of thing for equations 3 and 4 up here. And this one, pretty obviously, I can eliminate the C term if I multiply through the top by K prime and then add the two. That'll get rid of the C term. Or if I multiply the top term by k prime and subtract the 2, I'll eliminate the b term, and we'll have to do both of those in this case. So I've multiplied 3 by k prime. I get this. And now I add those two equations. The c's go out. The k prime, I'll get 2k prime b e to the I k prime w. And then when I add over here, I'll get k plus k prime, or k prime plus k on this side, at. And so I get these. And then ultimately solve for b, I'll have to divide through by 2k prime and multiply through by e to the minus I k prime w, which is this factor here. So I get that for b. And now then do the same thing. Now I'll subtract the 2. So subtract this top equation from this bottom equation from the top equation. That will eliminate this term. I'll get 2k prime c e to the minus I k prime w. And I'll subtract this. I'll get k prime minus k, but I went ahead and the k prime minus k, I factored out the minus to get k plus or minus k prime with a negative sign overall. And then finally just divide through by c, or by 2k prime. So I get a minus k minus k prime over 2k prime at, and then I multiply through by e to the I k prime w to get equation 7. Well, now then, we're pretty well set up in that I've got equation 5 here, and if you look at these two, the thing that's unique about B and C is they only depend on the transmission amplitude. And that's really kind of what makes this method work. So I'll plug those for B and C back up here to get A in terms of really the transmission amplitude. So plugging in for B and C, the expressions of 6 and 7, I get the following. Kind of a mess at this stage, but take a look here. I've got k plus k prime over 2k, and then times b. So I've got a k plus k prime over 2k times b here, and b was k prime plus k, 2k prime a t, e to the minus k prime w, e to the I k w. And similarly, here's b. I've got k minus k prime over 2k times c. So I'll get a k minus k prime over 2k times c. But c, remember, was minus. I put the minus here. K minus k prime 2k prime at, e to the I k w, e to the I k prime w. And then I can factor out some common terms. Pretty obviously, if you look at this, I've got a 4k, I've got 2 times 2 k prime in both terms, so I'll factor out that 4k k prime. I've got an e to the I k w in both terms, so I'll factor that out. I've got an at, which I factored out this way. And what I'm left with, when I factored all those out, I've got a k plus k prime squared. I've factored out everything else here except for the e to the minus I k prime w. And in this term, I've got k minus k prime squared. I factored out the numerator, I factored out a, I factored out this, and I've got an e to the I k prime w. So I have that. So I simply rewrote wrote it again up here. K prime with the minus, so we've got all that. And then I said, well, I can divide through by AT, so I get A divided by AT is just this factor out front. And remember, the transmission amplitude is AT over A. So A over AT is just 1 over the transmission coefficient, T, times this ratio here. It's absolute squared. So I've got A over AT. So A over AT is just this expression. When I take the absolute modulus squared, I'll get an e to the ikw, e to the minus ikw, so that'll turn into 1. I square this, I'll get 4k squared k prime squared. And then I have to take the absolute modulus squared of this term in brackets here. But that's just the complex conjugate of it times the term itself. And so first I replace I by minus I, so I by minus I. And then this term remains the same. So this absolute modulus squared is the complex conjugate, which is here, times the function itself. And then I expand that out. So expand that out, I get this term for the term in brackets. And then I collected a few terms. If you look at these two, they have a common factor. K minus k prime squared, k plus k prime squared. And so I can factor that out, and then I'm left with e to the I k prime here, w, minus, I'm going to factor out well, I've got this plus this. This plus this. So I get e to the ik prime w plus e to the minus a k prime w when I factor out these terms with the minus sign. And then I multiplied by 2 and divided by 2 to get this. And these two terms stayed the same. But this factor here is nothing more than the cosine of 2k prime w. And I can use a half angle formula, which I never remember, I always go back and do. So I can replace that cosine term up here with with 1 minus 2 sine squared. And I get this. And then I just collect some terms. I'll get a minus 2 of minus 2 will give me a 4 k prime squared, k minus k prime squared sine squared, k prime. And then I've got this term plus this term. Those are the 2/4. And then I've got a minus k prime squared, k plus k prime squared, k minus k prime squared, times this 1 here, which is where that middle term came from. And I just define that to be g. So all this with the k's in it, I let that be g, which is here. And the rest of it I'll keep. So we've got the reciprocal of the transmission coefficient in that form, and we'll develop that a little further in the next segment.